we look at identifying the subsets as well as determining the number of subsets of a set with n elements. Now, we want to make a note first of all, before we look at the number of subsets within a set and identifying them. We want to note that every set is a subset of itself. That's the first thing. The other thing is the null set is a subset of every set. Okay? So I want to just make a note of that. Now, we have, say for example, a certain number of subsets in a set, and we want to calculate the number of subsets in a set, I should say, and the number of elements is n. Now, I saw somewhere online what they said. They gave this formula: the number of subsets in a set is equal to 2 to the power of the number of elements in the set. Alright, that's what they said. We want to examine this a bit, just by looking at a few examples and see if it works for them. So remember, this is the number of subsets in a set. Let me write that down here. That's the number of subsets. And this n up here, this is the number of elements in the set. Right, the number of elements in the set. Good. Now, let's look at a few examples. Suppose we have a set where the number of elements is 0. Which set could that be? It is the null set, of course. The null set. And then we see that big N, the number of subsets, according to this formula, it is equal to 2 to the power of small n, the number of elements. Now that is 2 to the power of 0. What is 2 to the power of 0? If you remember your indices, it is 1. So there is only one subset here. Okay, so it works so far for the null set. There's no element. The number of elements is 0. So the number of subset is 2 to the 0, which is 1. Okay, good so far. Let's look at another one. Let's say the number of elements, or let's write the set first. We have this set and we say letter A is in it. Alright? The letter A. Obviously, the number of elements is equal to 1. How is this going to work out now? we have 2. The number of subsets is 2 to the power of n. And remember, by the way, subset, in case you forget, it means how many sets you can list out of a big set. How many smaller sets, or the set itself, how many sets you can get out of that set. That's what subs, or well, not how many, but each set that you can form out of that set that you're looking at. Alright, the subsets of the set is all of those other sets that you can get out of that big set there. Now, n is 2. Big N, number of subsets, is 2 to the power of small n. In this case, 2 to the 1 is equal to 2. So there should be 2 subsets. I wonder what these subsets are. Let's see if we can get them out here. You have A itself. Oh, remember, the null set is also a subset of every set. So there are 2, the null set and A, the set that contains A itself. Okay, good. So it's still working. Let us try this. Let's say this is now our set. You have A, B, just A and B. You can see here that when you try to calculate the number of subsets, you have 2 to the power of 2, which is 4. You can get 4 subsets out of this. Let's see if we can list them over here. Alright, let's list the subset. First you have the null set. Nice. Then you have what? You have A alone. Okay. Then you have B alone. Yeah, you have B alone. Then you have AB itself. Alright, so that's 1, 2, 3, 4 of them. So you have all 4. Good. So you can see that. Let's try something else here. Let me erase this. And suppose you have another set. Suppose you have this set. You have A, B, C. Question: how many subsets can you get out of this, and can you list them? All right, let's look at this one. The number of subsets is 2 to the power of the number of elements. 1, 2, 3 elements. 2 to the power of 3. What is 2 to the power of 3? It means there are 3 2's and they multiply one another. 2 2's, 4 4 2's, 8. So there should be 8. Let's see what's going on here. There should be 8. What are they? You have the null set. Good. Then you have A. Then you have B. Then you have C. So we're looking at each of these. No elements, then 1 element. Let's see if we can go in order. 2 elements. You have AB. You have AC. 2 elements starting with A. Alright, we've done that. And then 2 elements starting with B. BC. How many do we have here so far, by the way? 1, 2, 3, 4, 5, 6, yes, 7. One more. Oh, the set itself, A, B, C. Alright, 8 of them. So we have all 8 of them down. Nice. Now I want to try one more. Let me erase this and we try one more. We have this set. We have A, B, C, D. Now, what I want you to do at this point is pause the video, calculate the number of subsets that you can get out of this set, write them all down, and then you come back and continue. So, go ahead and pause. Okay, you have done it, and you're back. Let's see what you did. What we have here is the number of subsets that you can get out of it is equal to 2 to the power of the number of elements in the set. How many elements do you have? 1, 2, 3, 4. There are 4 of them. So it is 2 to the power of 4. 2 to the power of 4 means you have 4 2's and they all multiply one another. 2 2's 4, 4 2's 8, 8 2's 16. So there should be 16 subsets. Good. So the number of subsets that you should be able to get out of this is 16. Alright. Now, what are those subsets? Let's go ahead. We have, first of all, the null set. Nice. Let's list all the subsets with one element in them. One element in each. There's A. Then there's B. And there's C. And then there is D. Alright. 1, 2, 3, 4, 5. We have 5 so far. So, we have a total of 5 over here. Let's box up these 5 so we don't lose count. Now, suppose we have those subsets with 2 elements in them. So we have AB. Remember, AB is the same as BA. It's the same set. It doesn't matter which order you put them. So you cannot write BA after this. You have AB. Let's continue starting with A. AC. And you have AD. Alright. So that's 3 of them so far. Let's look at those with 3 elements in each. We have A, B, C. Then we have A, B, D. Alright. Then we have ABC, ABD, ACD. Here, let's see how far we have reached so far. 1, 2, 3, 4, 5. There are 5 here. Plus 1, 2, 3, 4, 5, 6. We have 6 of them in this box. So that's 6. 6 and 5, 11. 11, 12, 13, 14, 15, 16. We have 5 more to go. So we have AB. Okay, I missed out something. If I was going in order, I would have done more of these with 2 elements in them. We've done 2 elements starting with A. Let's look at 2 elements starting with B. We have BC and then BD. Alright. We have AB, AC, AD. Good. Starting with B, BC and BD. Good. Starting with C, we have CD. We seem to have completely run out of all of those with 2 elements. Now, we have 3 elements: ABC, ABD, BCD. Good. So 6 and 5, 11, 12, 13, 14, 15, 16. 2 more are left. What do we have here? We have the null set. We have those that contain 1 element. Then those that contain 2 elements: AB, AC, AD, BC, BD. We have CD. Those are 3 elements: ABC, ABD, ACD. We didn't have BCD. BCD. And then we have the set itself: A, B, C, D. Alright, so that's what we have. So far, the null set. Then those with 1 element alone, have A, B, C, D. Those with 2 elements starting with A, AB, AC, AD. 2 elements starting with B, BC, BD. 2 elements starting with C, CD. Then 3 elements starting with A, ABC, ABD. 3 elements, ACD, right? 3 elements starting with B, BCD. Then we have all 4 elements. So do we have everything? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? All 16 of them. So we have all 16 subsets. Alright, so we'll continue with this topic later on. We're done for now with this video, so I will see you later.